So our next presenter is from Novo Nordisk. It's Diego Olivares Garcia, and he's going to be speaking about work cell to automate sample preparation for chromatography analysis. And while he's getting that set up, Diego is an IT/OT architect, CMC QC technology and IT at Novo Nordisk. Background, mechatronic engineer, master science, industrial engineering management, 4-year FAE for factory automation, Mitsubishi, 3 years automation lead for Omnia, which is a software company for industrial data standardization, 2 years, and then IT/OT architect doing lab automation projects. Perfect. So I guess we'll go ahead. Diego, we can see you. Let's double check that we can hear you. And if you want to start presenting your slides.
Thank you so much for a nice introduction. So I'm not going to introduce myself anymore. So I'm just going to start directly with the project. And so the last year we have been working in automating the sample preparation for solid samples for tablets and powders in our CNC area. And then this work cell that you see on the left side is a machine that we built ourselves, everything. Yeah, so since we have the control of the whole project, we wanted to create something. We had this opportunity to create something with very nice data flows and how the data looks like and so on. And Allotrope was a very good solution for us with the ASM, with the simple models, to be able to especially interact when it comes from control to the operation of the devices. And so what we wanted to do was we wanted to prepare 100 samples a day to be ready to put in an HPLC. Make sure that we have data integrity and compliance, that the machine that you just saw routes automatically to LIMS. And then we wanted that all the data was somehow unified from all the instruments and devices. So when I say all the data, at least monitor, control, and audit trail, historical data. Yeah. We wanted to after we produce the data in the machine, that data engineers can just use it and spend way less time transforming it. And yeah, so I guess the last two, they're not that relevant, I think. This is just a small, to put some picture in your head. I place an ASM label on top of every device that produces data in an SAM format. And I'm going to show you a video later when you're going to see what is this. But then this is a Fanuc robot arm. Here we have two code readers that read barcodes. Then we have a Mettler Toledo balance here underneath. We have a pump under the table that is pumping liquid into the samples. And then I place these three that are in another color because they're not officially any Allotrope simple model. But we basically follow the same rules and formats to make these ones to be able to interact with it. And I think I have a pending with Benjamin and Amnon to send the liquid handler. This is a Tican Cabro. It's called the family liquid handler. I owe Amnon and Benjamin on this one to share what we did. And then this one, it's a PLC that we use with the same philosophy. But of course, we're never going to be able to standardize many of the things of a PLC. So we have not really tried to push that to Allotrope. But yeah, maybe we'll have some discussions on how we can do something generic enough that it makes sense to add. But and we also try to use the same philosophy to connect to LIMS. We did some kind of modeling for the communication in and out from LIMS. This is having a PC that is controlling everything, and the PC is the one that controls everything and also controls the communication towards our LIMS system. Our main challenges, the old same boring ones, like none of the device has any standard when it comes to data or control. We use a control system that is developed by a company called BioZero. That is just to control the work cell. And of course, there's no out-of-the-box way to handle a response or the data as it comes from an allotrope model, but no one does that anywhere. So this is kind of an advantage and a disadvantage at the same time. Let's just say it like that. Then we have to implement all of this in all the devices, adding an extra layer of control or an extra layer of translation between the control system and the devices. And the more we implement, the more we have to validate, because this is going to be for GMP production. And then the next bullet point, one of the challenges is we wanted to collect absolutely all the data possible for the one that we know we need today, but we also wanted to be ready for whenever somebody wants to do something smarter. But when you ask management or you ask around, nobody really says, I need to gather this data because I want to do this or that. And then we have to spend some time deciding what data is important and what data is not. And the last one, and this is nothing to do with allotrope, but you might have noticed that our project is very strongly automation focused, and for us the data model is a very, very, very good help, but there's more things involved on what do you need to do to actually control an instrument. You need a communication protocol. You need to send commands. You need to receive commands and things like that. And that functionality needs to be added somewhere. And there's also no ready-made tools to do that. So there's a lot of work on us on how to do that. Just a very small walk through the architecture of the system. Please don't pay too much attention to the detail. I'm just going to divide it in simple blocks. On the left side, I don't know if you can see. Can you see my mouse?
Yes.
Yep.
Yes, maybe I can use the pointer. Is that did I do something wrong? No. No, okay. If you can see my mouse, I'll just do it like that. In the left side, I'm just explaining that the networks across the company, and the information needs to flow from different networks all the way where from the lowest level, that it's the hardware, to the PCs on the laboratories, all the way to all the cloud systems. You know these names, right? The data lake and the LIMS system and whatever it is. And then see this small section as a physical laboratory where all the devices are connected to the network blocks with an Ethernet cable. And that's where the computer connects to the devices. And here is where, with the help of the framework of SILA 2, we wrap the functionality for control of all the instruments, and then we wrap that the response of each of the instruments follows the information of the data of the ASMs. And then this is where the project has the highest focus. And then the rest of the integration through the control system is just, it's not done yet. It's done yet to the minimal degree that it actually writes to LIMS, but it's also open. It's a REST API based control software. So whenever we want to do more integrations from this same application to other applications, then we would be able to do it. And then I can go. Did I change to? Yeah. Well, just quick overview. So then we say instruments, then we go to the instrument harmonization layer, then control, PC, then we go to scheduling, and then we go to all the corporate systems. Some of our results on this, probably I should, maybe I should have shown the video first. But so once you have implemented, you have decided how to implement this, and you have the SILA implementation, and everything follows the allotrope ASMs. To add new devices and to know how to control and to read, and it becomes extremely easy. And then you don't have to figure out how to do new integrations when you get new instruments, and you know how to read the results, and yeah. Then the next thing is like every time you see the response that you get from each of the individual instruments, you can read it. So you can use it either for troubleshooting, but you can also then, mass store it and then do something smart with it later. But also, something that was very useful for us is that suddenly we came and the machine has failed, and then some of the data was not pushed to LIMS or whatever. And then when we wanted to recover all this information from the audit trail and so on, it was very clear for us what was going on and which data was there and where to put it. And yeah. If I would say the cons, it has to do with the adoption, right? Mostly it has to be with the adoption. In this case, implementation of the ASMs, as you saw, we have to do all of that ourselves, and obviously in an ideal world, I can see that I deleted something that goes here. We should. We would like manufacturers to adopt this kind of modeling. So we have way less work on implementing these things, and we just focus on how we read and control using the standards that Allotrope is providing us. And the second one is like when we were implementing it ourselves, of course, all the devices are different, and some manufacturers decide to expose some of the data, some of the manufacturers decide not to expose some of the data. And then when the data is not there, we cannot extract it and we cannot use it to completely fill the ASM. But yeah, that's the way it is. But yeah, I guess we would like to encourage manufacturers to follow models like that. And then I added a last slide. And so from what you saw, what we're missing now from the integration, like now what you saw, I'll show you a video that is working. But it stops on the necessary. So it runs the machine, it writes the results to LIMS, and it only writes the data that we need to be able to fulfill the application and compliance. The rest of the data and metadata, we're not using it. We're not using it right now, but now we have it all available. And what is next for us to work with is with all this integration with the APIs to be able to push it to the cloud. But the thing is now our machine, the source of our data, produce very nice, clean, and complete data. So whomever wants to do something upwards in the architecture, it's going to have a much easier time than they usually do. Yes, so that's for my presentation. Then I would just like to share a small video. Tell me if you can see it.
Yes.
Yes.
Yes. So there's a lot going on, but this is our samples in the bottles, right? And this is the balance where it's putting it. There's a scanner reading below the ID of the bottle. Then there's a scanner on top that maybe you cannot see right now, a bit of the screen, that is reading the sample identifier that was on the cap. And then now the balance is taking the measurement, the Mettler-Toledo. It's a Mettler-Toledo balance. And back. And then after doing all of them, they're just gonna dissolve them. And then we use the liquid handler to transfer them to the microtiter plates. So at the end, we can put them into the HPLC or analysis. And then, yeah, it's closes the samples and, yeah, ready to pick them up. And so, yeah, so that is my presentation.
Great. Thanks, Diego.